All right, welcome. So this is integrated science. The question is coming from question paper 2021, paper 1, question number 10. So we have this cell over here. By the way, we have an electric circuit. Have a switch over there. The cells, we have instrument S, and this is known as a rheostat, also called a variable resistance. Then R is a resistor. Of course, we have 3 ohm resistor. Then we also have a 6 volt. So this part we have a voltmeter, and we go straight to the question. So the first question there, according to the posted question, it says define a voltage. So voltage is just the force that makes electrons move in a conductor or a circuit. Simply put, voltage is the force that will make electrons move. If there is no force that is pushing them, electrons will not move at a constant pace. We can also call that as an electron motive force, abbreviated as EMF. So we just call that as the force that makes electrons move in a conductor. Then the B part says name instrument S. So S is the ammeter. The meter S is the ammeter, because here we need to have 3 components. We need to measure voltage, current, and resistance. So we are remaining with S, which should measure the current. So the third question, C, says how many cells are shown in the circuit above? So this circuit shown has cells. These cells are in pairs if you want to count them. So you say this is a positive and a negative, a positive, a negative, a positive, a negative. So we count them in pairs. We have 1, 2, and 3. So we have 1, 2, 3. So here we have 3 cells in this circuit. D, calculate and state the meter reading when the switch is closed in the circuit. So the switch is open, as you can see here. The switch is open. If we close it, it means that electrons will now be flowing around and transferring that electricity to the resistors, and the voltage also be passing through the conductor. So on the D part, we need to find the reading. So we know that from Ohm's law, current is equal to voltage over resistance, where current is abbreviated as I, voltage with capital letter V, and resistance with capital letter R. So our current at S will be equal to the voltage we've been given as 6 volts from the voltmeter right here. So we have 6 volts over the resistor. The resistor reading in this case is giving us a 3 ohm resistance. So our current is equal to 2 amps. Current is measured in amperes, so this is amp, capital letter A. This is our current reading right here. Question E, what would happen to the reading at S if voltage is doubled at R? And R remain the same. So if we maintain the resistance, what will happen to the instrument S? What will happen to current, in other words? So you double the voltage, you also double the current. That's what will happen. For example, if we double the voltage here, we say voltage becomes 12, resistance remains the same. The current reading, you see that it will go up to 4 amps. So you double the voltage, you double the current. Now the last part says, what does the result in the meter reading at S show about the relationship between voltage and current? So from the previous calculation here, we could see that it shows the relationship between current and voltage, but what does it show? So the answer is that it shows that when the resistance is maintained in a circuit, you double the voltage, the current is also doubled, or vice versa. So you double the voltage, the current will also be doubled. So this is the question on electricity for integrated science in 2021.